So the question says, study the wave pattern. It takes 0.5 seconds to complete the pattern from A to B. One wave is up until here. That is one wave. Okay? And then the second wave is from there to here. There are two waves that complete that point in 0.5 seconds. So there are two waves. That is important before we even carry on. Question A. Name 2 points that are in phase. Let me just write this one. We answer those. So this one is A. Let's answer here. 2 points that are in phase. First, easy, is B and F. So B and F, they are in phase. More, D and G. D and G. Are there more? Yes. A, E, and H. Those three are in phase. Alright? So I'm going to write A, E, and H. Those 3 points are in phase. Why are they in phase? They have the same motion at the same time. Is that clear? Amazing. Between which 2 points does the distance represent one wavelength? And then we said yesterday between the 2 crests, that is one wavelength. So, for instance, B, between B, I'm not going to write between, you know it's between the points, B and F, that is one wavelength. Remember, points in phase, if they are consecutive, it means that is one wavelength. And they are consecutive, we mentioned before. What else? Between D and G, that is one wavelength as well. Between A and E, that is one wavelength. Between E and H, that is another wavelength. All this one represents one wavelength. Is that clear, my lovely? Any question there? No? Okay. They said which line represents the rest position. Remember we mentioned there is not a line here. So will be the points that if you join them, they will form a line. And we say that line would be, let me just make a line so you can see it here. That line is if you join all these points from A to H. That here represents the rest position. So if you come here and you write this one is rest, hey, no with that one. Rest position. So this one is question C. What are the points that if you make the line will represent the rest position? A, C, E, and H. And we mentioned yesterday that you cannot say from A to H, because from A to H include all the points. It's A, B, C, D, E. So it's not like that. It's the points that if you join them, they will make a line. That is the question there. Now, what is the amplitude? The amplitude is the distance from rest position to the crest, or from rest position to the trough. Is the maximum displacement of the particle from where? From rest. So here, the rest position, the amplitude pattern will be this distance here. That one there is the amplitude. From rest, isn't that line rest? So from rest to crest. Or from rest to the trough. So that distance or this distance. That one will represent the amplitude. This here is the amplitude. Do you understand that one? Saying that, how much is the amplitude then? This one is 20 divided by 2. There we go. You don't have to write 20 divided by 2. It's easy. It's 10. So the amplitude is 10 centimeters. Is that understood? So they gave you 20, but 20 is not the amplitude. 20 is more. It's double. Is that clear? Wonderful. What is the period of the wave? Now, what is period by definition? Somebody, just the time of what? You just give me time. What is period? The definition of period. Vibration. So it's the time for one wave. Do you understand? Is the time for one wave. How many waves are there? How long it takes for two waves? Therefore, how much will take for one wave? 0.25. Let's write it here real fast. You say two waves, because period is for one wave, time for one wave. Is that correct? It takes how much? 0.5 seconds. One wave, how much will take? This one is simple math, and I'm going extremely slow. You do cross product. Now this one is simple, but sometimes it's not that simple. That's why I recommend you to do it in this way. It's mathematics, simple math. So you do cross product, and what will this be? 0.5 times 1 is equal to 2x. Are you following me? So x is equal to 0.5 divided by 2, which is 0.25 seconds. So now we have the period. I'm going to write it here. I'm just going to write it here. Period is 0.25 seconds. It's not, you don't need to do it like that because it's simple. In this case, it was 0.5 divided by 2. Calculate how long it will take 5 complete waves to pass a point. And we're going to repeat what I just said here, but applicable for that 5 complete waves. All right, they say how long in time will take 5 waves to pass a point. So we are going to come back here, and we are going, oh, what am I doing here? We're going to go back here and repeat what I just said, but now they're using 5. Are you there? So let me write it there. I think you will be able to see. So you say now, how many waves? 5 wave is how long? X. You don't know. They're asking you. How long will be 5 waves? So 5 waves will be X. Maybe I should write waves. So you know we speak in 5. That 5 is 5 waves. It's going to be X. Can you see there? Let me move there. There we go. How many waves do we know exactly? 2 waves takes how long? 0.5. And I'm going to repeat my cross product. 1.25 seconds. That is the answer. 5 waves will take 1.25 seconds to pass a point. Was that clear? So that answer is for here. Let me clean that one. 1.25 seconds. There we go. What is the wavelength of the wave? Now let's go back again. What is wavelength? It's the length of the wave. Of how many waves? One wave. We go back to the picture. What is the wavelength? It's 1. Because this distance here is for 2 waves. So 2 meters for 2 waves. Wavelength is for 1 wave. How much will 1 wave be? 1 meter. Okay? That is why they don't say calculate. They say what is, because the numbers are there. So the wavelength that you can see here, quite simple, is going to be 1 meter. Do you understand why 1 meter? Huh? Calculate the frequency of the wave. Now it's a formula to use. Very easy formula. How do we calculate frequency, my lovely children? This one is what? mH. Frequency is equal to 1 over period. Easy peasy. Is 1 divided by period is 0.25. Careful, confusing numbers here, eh? Frequency is equal to 1 divided by 0.25. Is 0.48. So let's fix that one. It cannot be 0. It's a 4 the unit is hertz. We are done. If you do this one in the test, this one will be 1 mark for the formula, 1 for the substitution, 1 for the answer. Okay, and then final, calculate the speed. What formula can we use here? We can use many. So let's use all of them just in case, so you understand. Okay? So let's go to option 1. Option 1. Speed is equal to frequency multiplied by wavelength. Are we there? You do have that formula, don't you? In the book. Speed is equal to frequency 4. Wavelength 1. Speed is equal to 4 meters per second. Option 2. Another way to do it. Speed is equal to distance divided by time. That is option 2. What is the distance here? The total distance. 2 meters. You see? 2 meters. What is the total time? 0,5. We're talking about total distance for total time. Right? A 0,5. So we got speed equal to 4 meters per second. Are you following me? And option 3, let's write it here at the bottom. You don't have to do all of them. I'm saying different ways of doing it. Maybe not everyone use the same option. Okay? Option 2 is wavelength. Speed is equal to wavelength divided by period. So we can also do that. The wavelength is 1. The period was, what was the period? 0,25. Answer is 4 meters per second. There we go. Answer. All the answers were the same using different methods. You do not have to use all of them. Was that clear?